We're going to do some extra examples for lesson 7.1. And so we're talking about predicting the population of bacteria for each situation and time period. So we're going to start with 80 bacteria that doubles every hour. So initial amount is 80. It's doubling, so that is my multiplier, and it's happening every hour. So a general expression or equation for this would be 80, the initial amount, times my multiplier to the power of time. And in this case, time stands for number of hours. And so after 2 hours, we want to know what happens. We take our equation, 80 times 2 to the power of 2. And we put that in our calculators, and we find out that we have 320 bacteria after 2 hours. All right, when we want to know what happens in 4 hours, we start with our initial amount. It's still doubling, but we do a power of 4 for the 4 hours. We put that in our calculator, we get 1,280 bacteria. Now, when you put these problems in your calculator scientific knows the order of operations. So we just want to make sure that when we type it in, we type in 80. You don't need parentheses, I just have a habit of it, to the power of 4. And we get that 1,280. The reason I want to bring this up is when you put this in the calculator, your calculator knows to do the power first and then multiply. So if you're doing this by hand and you type 80 times 2 and then you turn around and put that to the power of 4, that is going to give you an inaccurate answer. If you're doing multiple problems, I would just come in here and change it. There's my power of 2, and we hit enter. We have our 320 bacteria. All right. We are now changing it a little bit, and we're starting with 140 bacteria, and they're doubling still, but it's every half hour. So we want to be careful with our power. So this would be 140 bacteria times 2, that's my multiplier, 200%, and it is to the power of t, but t stands for the number of half hours. So when I go to do 1 hour, t is going to be 2, because there are 2 half hours. Or I could simply take 1 hour times the 2 half hours in that, and there is my 2. So plug it in, 140 times 2 to the power of 2, and that gives me a total of 560 bacteria. All right, we go to 3 hours, and so my time for 3 hours, the power is going to be 6. There are 3 hours times 2 half hours in each one, and that's where we get the 6 from. So 140 times 2, none of this changes. Initial amount multiplier, the power is what's changing, and we get 8,960 bacteria. All right, and the next problem, we're still doubling, but I want to remind you that if I was tripling, then I would just multiply by 3, okay? So if it was tripling, it would multiply by 3. This time it's every 15 minutes. So there are 4 intervals of 15 minutes every hour. 4 intervals of 15 minutes every hour. And the time was given us in hours. So we're still going to start out with our 230. We're still doubling, so times 2 to the power of time. And time stands for number of 15-minute intervals. So in 2 hours, every hour has 4 intervals of 15 minutes, so that's really 8 times. It's doubling 8 times in 2 hours. So we have our 230 times 2 to the power of 8. And that gives us 58,880 E. coli bacteria. And in 6 hours, that's 230, same amount, times 2, but 6 hours times 4 intervals each is going to give us 24 times. So the idea is in 6 hours, the bacteria is doubling 24 times because it's happening 4 times per hour. All right, this gives us a pretty large number. So we have 3,858,759,680. And so that's our answer, but let's add on one quick idea. If I told you to round this to the nearest 100,000, round to the nearest 100,000. What would that look like? All right, for the nearest 100,000, we would be looking, here are our hundreds, here are our thousands, so 1,000, 10,000, 100,000. So our answer around the nearest 100,000 would be 3,858,800,000, and everything else after that zeroes out. So be very careful to what you're rounding to. All right, 3,858,800,000. The 5 tells us to round up. We're following the rounding rules. All right, we have one last example, and it is a word problem, and it's about a population growth. So this is a made-up town called Geyser, and the town has 85,450 people in it, and that's in the year 2020. The population is projected to grow at a rate of 2.4% per decade. So we want to be careful with two things. It's not just an even 2 or 3%. It's not a nice whole number. It's 2.4%, and it's per decade. We want to predict the population in the year 2035 to the nearest 100, not 100th, but 100. So we start off with 85,450 people in this town, and it's growing at a rate of 2.4%. So I would take my 100% of my population and add on 2.4%. That gives me 102.4%. And I like working with the percents because I'm not going to mess up my decimal as easily. So I'm going to convert this to decimal by dividing by 100% or moving the decimal 2 places to the left. And that's what's different. It's not 1.02, it's 1.024 for that 2.4%. So always watch your decimals and to the power of time, and we're going from 2020 to 2035. So 2020 to 2035. Well, that's 15 years. So what is that in decades? Well, 10 years in each decade, so take 15 divided by 10, our power would be 1.5. So we'd be very careful with that. All right, so you're going to type that into your calculator. 85,450 times 1.024. I don't think it hurts to double check that you typed in the right numbers, to the power 1.5. Again, if you misinterpret this and you put it to the power of 15, you're going to get a very different answer. Once we hit enter, we get this large number, and it told us to round it to the nearest 100. So the number I'm getting in my calculator is 88,544.6 if I round it. But we're asked to round to the nearest 100, so that would be 88,500 people. And that would be in the year 2035.